Here's another reaction that occurs in aqueous solution. So let's write the net ionic equation, which is getting rid of the spectators and showing just the participants in the reaction. All right, what do we got here? Iron 3 nitrate. So iron is Fe, and this transition metal is going to have a 3 positive charge. That's given for us. Nitrate is NO3 with a 1 negative charge. So 1 negative and 3 positive. We're going to crisscross those charges to get the formula. All right, so that's why I use the parenthesis here, so I can get multiple polyatomic ions, and let's put AQ to indicate that's dissolved in solution. And sodium hydroxide. Hydroxides are generally insoluble or very slightly soluble, but sodium and potassium are your important soluble ones. So sodium is Na, hydroxide is OH. They both have a charge of 1, so they're going to cancel out, and we'll just put AQ there for soluble. All right, and these double replacement reactions, you're just going to switcheroo the cations or the anions. All right, let's do. I'm going to write sodium first because your alkali metals and your nitrates are always going to be soluble. So I want to put my precipitate at the end. Doesn't matter though. All right, Na is sodium, and now that's going to pair it with nitrate. And again, they both have a 1 charge. Okay, so they're going to cancel each other out. But let's indicate that they're soluble by putting AQ. And the other compound is going to be iron. Now this is iron 3 now, and that's going to partner up with hydroxide. All right, hydroxide is a 1 negative charge, and iron, and this one is a 3 positive. So we're going to need 3 hydroxides for every iron to make this a neutral compound. All right, again, hydroxides are generally insoluble, and iron is not an exception. So this is going to be your precipitate. All right, let's balance this. Can we do this without showing our work? All right, we got 3 hydroxides there, only 1 on the left. So let's put a 3 here. Right, now we got 3 sodiums and only 1. And that should do it. Okay, usually you can do it. A lot of these double replacement reactions like that. All right, and then now you have 3 nitrates on both sides and 1 irons on both sides. Everything is balanced out. All right, so now let's rewrite all the aqueous substances in dissociated free form. So iron, Fe, and that's a 3 positive cation in this case, and AQ. And there's 3 nitrates, so I'm going to bring that up here to the coefficient. A lot of times you can balance this at the end. I'm just going to as I go. All right, we need the charges here because these are now these are freely floating around the water. Okay, sodium, there's 3 of them, and there's 3 hydroxides, all floating around this solution of water. 3 hydroxides, AQ. Don't forget your charges. All right, and we have, that's a negative sign. I'm going to go down here. I feel like I'm going to run out of room, but I'm trying to keep it on the same line. Should be. All right, 3 sodiums, AQ, and then plus. Don't forget your plus signs. Sometimes students forget them. Don't know why. And then 3 nitrates. Don't forget the charges either. That's AQ. And then this is not soluble, so we're just going to write that just the way it is. Iron 3 hydroxide precipitate. All right, so we need to cancel out the spectators, cross them out. So we have, really, you're going to get the hang of this. There's going to be a pattern here. Anything that's not part of that precipitate oftentimes are your spectators. So your nitrates are spectators and your sodium ions are your spectators. And let's just rewrite whatever is left to get our net ionic equation. All right. You have your iron cations. They're going to react with the hydroxide anions to form iron 3 hydroxide precipitate. And I didn't do this earlier, so why don't we balance this? Yeah, why not? All right, so we already balanced this earlier. So you know the atoms are balanced, the charges are also balanced. I'll balance the charges. All right, so the charge on the product side is 0. There's no charge there, all right, because they cancel out. And the charge on the reactant side is a 3 positive from the iron, and then the 3 negative charges, and so they cancel out to also 0. So the charges balance out on both sides, and so do the atoms, and this is what we call the net ionic equation.